All right, let's just go through a few more examples of simplifying trig expressions and verifying trig identities. So this first one is pretty straightforward. We just have tangent over sine. So here I could split this up and write this as tangent, which we know tangent is equal to sine over cosine times 1 over sine, right? Well, then the sines cancel out, and I'm left with 1 over cosine, and we know 1 over cosine is just secant. Okay, so there we simplified this to a single trig function. All right, in the next one, we may be tempted to multiply things out here since we see two sets of parentheses, but this is actually going to work a little bit better if we just think about what's on the inside first. Try to simplify what's on the inside. So first, cosecant squared minus 1, that is one of my Pythagorean identities, right? That is just cotangent squared, right? So I can just make this cotangent squared. And then here, well, I know that secant is the same as 1 over cosine. So I could rewrite this as 1 over cosine squared times sine squared. Well, then we've got cotangent squared times sine squared over cosine squared. Well, sine squared over cosine squared is tangent squared. So we just end up with cotangent squared times tangent squared. And then I know that cotangent squared is the same as 1 over tangent squared. These cancel out then, since there's 1 in the denominator, 1 in the numerator, and I just get 1. So this whole big mess at the beginning just ended up equaling 1. All right? Now let's verify a few identities. So in the last few, we just had to simplify to a single trig expression. Here, we know the answer, right? We know what the answer is supposed to look like. So let's start with the left side here. I know that cotangent squared is equal to cosine squared over sine squared. Well, now, if I want to do this subtraction, I would need to get common denominators. So I could multiply this by sine squared over sine squared. So then we've got, let's go back to blue, cosine squared over sine squared minus cosine squared sine squared over sine squared. I've got my common denominators now. I'm just subtracting the numerators. So I'll go ahead and write that out here. Cosine squared minus cosine squared times sine squared. And now, in my numerator, I can factor out a cosine squared. When I do that, I would have cosine squared times 1 minus sine squared. And now 1 minus sine squared is a manipulation of one of the Pythagorean identities. 1 minus sine squared just ends up being cosine squared. Well, cosine squared times cosine squared would just be cosine to the 4th over sine squared. And 1 over sine squared would be cosecant squared. Okay, and that is what we wanted to show, right? Cosine to the 4th times cosecant squared. So we had to get common denominators, we had to factor out, we had to use our Pythagorean identities. Okay, so there's a lot going on here. Right? We had to use multiple of those different strategies that we've talked about. All right, let's do another one. So here, I've got cosine times secant squared minus cosine times tangent squared over cosecant squared. Well, here, in the numerator, again, if I factor something out, if I factor out a cosine of alpha, I'm left with secant squared of alpha minus tangent squared of alpha. Well, again, this is a manipulation of one of the Pythagorean identities. Secant squared minus tangent squared is just equal to 1. So this ends up just being cosine of alpha times 1 over cosecant of alpha. Well, 1 over cosecant of alpha is just equal to sine. So this would just become cosine of alpha times sine of alpha. All right, and that is what we wanted to show. Let's do one final example here. All right, so in this one, if I'm adding these fractions together, I need to get common denominators. So I would need to multiply this fraction by 1 plus cosine over 1 plus cosine. And then this one by 1 minus cosine over 1 minus cosine. So my numerator here is just going to be 1 plus cosine over, now we talked about whenever we're multiplying by a conjugate, and in this case, we do end up multiplying by a conjugate. We have 1 times 1 is 1, 1 times negative cosine, and 1 times positive cosine. Those will cancel each other out. And then we've got cosine times negative cosine, would be negative cosine squared. Then something very similar over here. We've got 1 minus cosine over, and this multiplication will be the same, 1 minus cosine squared. So in my numerator, I've got 1 plus 1, that'll be 2, and then cosine plus negative cosine, that cancels out. The denominator then, 1 minus cosine squared, that's a manipulation of one of the Pythagorean identities. That is just equal to sine squared. And we know that 1 over sine is just equal to cosecant. So 2 over sine squared would be equal to 2 times cosecant squared. Okay, so those are just a few extra examples. Make sure that you are comfortable with all the different strategies that we've talked about. Multiplying by a conjugate, splitting a fraction up, getting common denominators to add something together, just changing everything to sine and cosine right off the bat, all those different strategies, and make sure that you have all of the identities memorized, okay? All 6 reciprocal identities, the 2 quotient identities, and the Pythagorean identities, okay? If you would like me to go through more examples, I'll be more than happy to. Just make sure you ask, all right?